everyone, it's Hannah from Sky Academy. In this video, we are looking at statistical analysis. There's two subtopics in statistical analysis, MS4 and MS5, and we are specifically looking at MS4 or Bivariate data analysis. In our first video, we looked at what a scatter plot is and how to draw one and how to read one. So a scatter plot would look like this. We would have a y-axis and an x-axis, and we would have points on the number plane. We would have a table of values determining what the points are, and we would have a title for the x-axis and a title for the y-axis. And these would be determining two variables. I'm just going to label them x and y variables, and we would use the scatter plot to determine if there was a relationship between the two variables. So if one increases, the other one will increase, or if one decreases, the other one will decrease. But today we're going to look at the ways to describe a scatter plot. So there's actually three ways to describe a scatter plot. We're going to look at each of these ways. But the first way would be to describe the form of the scatter plot. The second way would be to describe the direction. And the third way would be to describe the strength. So a question might ask you to describe a scatter plot, and you would use these three things to describe the scatter plot. So let's have a look at our first slide. And this one is looking at the form, so which was the first way we can describe a scatter plot. So there are two forms of an association of a scatter plot. There's the linear form, when points tend to follow a straight line, and there's the non-linear form, when the points tend to follow a curved line. So if we have a look at the examples down below, 1 and 2. Example 1, the points are tending to follow a straight line. So if I drew a line to mirror the points like this, it is a straight line. So we could call that one linear. If I drew a line to mirror the points for our second example, it's a curved line. So it would be non-linear. A helpful way to remember this, I find, is I write linear equals line. So we have L and L, and non-linear equals no line. So N and N. So that's how we would describe the form of a scatter plot. Now let's have a look at the next slide. So we are now looking at the second way to describe a scatter plot, which is the direction. So we can have, once again, two ways. We can have a positive, where the gradient of the line is positive, or we can have a negative, where the gradient of the line is negative. So if you remember, our gradient equals m, when in the form y equals mx plus b. This here is the gradient. And you can find the gradient by doing rise over run. And so if you do rise over run, you get a x value and a y value, and it comes out positive, then it's a positive direction. If it comes out negative, it's a negative direction. But if you have a look in these examples down below, we have two examples again. There is no values on the x or y, which means we can't do rise over run to determine whether these are positive or negative. Instead, we just have to look at it by eye. And so if I drew a line to mirror the dots again, a line that travels in this direction would be positive, and a line that travels in this direction would be negative. Now, once again, I have a little way to remember it. It might be helpful, it might not be helpful. I'm just gonna say it, and yeah, hopefully it's helpful. if we drew a number plane or a graph, when you're labeling X and Y, you have positive along here, 1, 2, 3, 4. You have positive and along here, 1, 2, 3, 4. And these two ones here would be negative. So this here would be -1, -2, oops, -2, and so on. And the same for here. We'd have -2, -1. We'd have 1 and we'd have 2. And 1, 2, and this here would be -2. And so a positive direction, anything, if you highlight underneath the line, the values will be traveling along the x-axis in towards a positive line. But if you're in the negative, they are traveling along the x-axis towards the negative x values. So along here, we're going along this way, which is towards the positive x-axis, 1, 2, 3, 4. And if you're going this way, it's going along towards the negative x-axis, -1, -2. So that's how I remember it. I draw a line, then I color everything underneath, and I go, is it heading towards the positive, along the positive x-axis, or is it heading along the negative x-axis? So if that's helpful, that's great. If not, just remember you can do it through gradient, rise over run, or you can just remember the direction of the arrow. So if it's going this way, positive, and if it's going this way, negative. So now let's have a look at our third way to describe a scatter plot, and that's the strength. So there's 3 ways, or there's generally three strengths that each scatter plot could be. They could be strong, which is a small amount of scatter in the plot, so they're generally like all together in one clump. Or moderate, they're like a modest amount of scatter in the plot, so they're kind of together, but they're also kind of spread out. And weak is when there's a large amount of scatter, or they're really spread out in the scatter plot. So if we have a look at this first one here, they are all clumped together in one line. So if I drew a line, they're almost all on top of the line, which means that would be strong. If I drew a line on our second one, they are kind of all towards the line, but they're a little bit spread out. So that would be our moderate one. And if we have a look at the third one, and I drew a line, they are really spread out, they are scattered all over the place, and so that would be a weak strength. So strong is when they're almost all in a line, moderate is when they're kind of in a line, and weak is when they're spread out. So if I was to have a look at this first example again, I would say that it is a strong association. I would say that it is linear because it follows a line. And I would say that it is a positive association because everything under it would be going towards the positive x-axis. So those are our 3 ways, whether they are positive or negative, whether it's linear or non-linear, and then whether it's strong, moderate, or weak. So let's have a look at our next slide. We have an example describing bivariate data sets. Let's read the question. The table below shows the height in centimeters and weight kilograms of 9 people. So they're our 2 variables, height and weight. And once again, I'm just going to quickly write on whether this is X or Y, just for myself to know. So it says A, construct a scatter plot using the above table. All right, so a scatter plot, as you know, we have our Y and we have our X axes. I'm going to go and write that on there. So we have our Y and we have our X, and I'm going to label them. So our X is height in centimeters, and we have our weight in kilograms. All right, now I need to plot the points. So I need to get a scale. So I am going to go up by, let's have a look. I'm going to go up by 5s. So my scale here is going to be 5, and my scale here is going to be, let's try to, we might have to change it. All right, so our height on our x-axis, I'm going to start with 160, 165, 170, 175, 180, 185, 190, perfect. So I'm going to go write that in, 165, 170, 175, 180, 185, and 190. And then my weight or my mass is going to be on the Y, and we're going to do 2s. So I'm going to start at let's start at 54. 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 70. No, I'm going to have to retry that one. So it might take a little bit of trial and error to see which scale works the best. 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. Let's just do that. So we had 54, 56, 58, 60, 62, 64, 66, 68, 70, 72, 74, 76, 78, 80. So when you're drawing this on paper, you should use a ruler to measure the distance between each interval. You might make it 1 centimeter or 0.5. Just make it an even amount. It will make your graph more reliable. Obviously, I'm on a computer, so I can't get out a ruler, well, I could try, but I'm not going to get out a ruler. So my graph won't be as accurate as yours should be. All right, now we have to plot our points. So we have, I'm going to do that in just red so I can tell the difference. So we have 163, which might be about here, and 55, which would be about there, maybe. 165 and 60 should be about there. I'm actually going to move this one over because I think it's more like 164. Here, 163. Okay, hopefully that's right. Then 170, 164, 175, 66, 178, 65, 180 with 70, 182 with 71, 186 with 74. I hope that's right. And 190 with 78. All right. Now let's have a look. That's question A done. Describe the form of the association. So if it's a linear or nonlinear, this is generally a straight line. So I'm going to say linear. Describe the direction. If I drew an arrow, it's going along all the positive x values. So it would be a positive association. Describe the strength. They are pretty much in one straight line. A couple of them might be a bit below or above, but they're generally in a straight line. So I'm going to say strong. E, predict the mass of a person who is 173 centimeters tall using the scatter plot. So I have to go to height. I go across to 173, which might be back here. And I need to draw in a line first. Let's go like that. And okay, so 173 would be maybe here-ish, I'm hoping. So I go up till I reach my line, and then I go across. So I'm going to say 65 kilograms, and predict the height of a person whose mass is 75. So 75 would be about here. And if I went down, I'm going to say 187 centimeters. So that's how you would describe bivariate data sets with the 3 different ways of describing form, direction, and strength. It's how you draw a scatter plot. If you remember back from our first video, you have your y and your x axes, you write your scale on, you put in your titles, put on your points. You can draw a line through the points if you want. And then for E and F, you go across to the value they give you. So they gave us 173, so we go across to 173, and then we went up to where we met the line, and then we went across to get the height, or I mean the weight or the mass. And then we predicted the height of a person who has a mass of 75, so we went up to 75 on the mass, went across till we met the line, and then down. So using these dotted lines, I would recommend. It reduces the chance of errors. You can follow where you're going across, and then you can go down. So that's how you would do that example. Now let's have a look at this second example. So the table below shows the time taken, hours, relative to the distance traveled. So there's our 2 variables, the time taken and the distance traveled. I'm going to go ahead and write x and y so I remember x and y. Draw a scatter plot using the above table. So our first step would be to draw our x and y onto a number plane. There's my x and y, and I'm going to label them, and I'm going to put the titles on. So that's y, that's x. X is distance, and y is time. And now I need to get a scale. So for distance, I'm just going to use the scale they've given us, which is going up by tens. So that's lovely, scale of 10. And for my time, I'm going to use a scale of 0.2. No, let's just go 0.5. Hopefully that works. I might have to change it. All right, let's put in our distance. So we have 10, we have 20, we have 30, we have 40, and we have 50. And I'm going to do, oh, I want 0.05, sorry. Okay. So we have 0.25, then 0.3, 0.35, 0.4, 0.45, 0.5. Nope, that's going to take too long. Let's just do 0.1. Let's just do that. So 0.2, 0.3, 0.4, 0.5, 0.6. Nope, still not going to work. Okay, let's try and move these again. Whoops, I just got rid of my Y. That's fine. Okay. Try again. So let's have 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 0.1. 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, and 1. Oh, let's fill in those things. So then there, 3.8 might be about there. 30 with 5.9 might be about there. 40 with 8.2 might be about there. And 50 with 1.0 might be about there. So now I'm drawing my scatter plot. Which are the independent and dependent variables? Right. So independent is always the x-axis. And in this case, that is distance. And our dependent is always the y-axis, which in this case is time. Now, a helpful way to remember this is the independent is like the ground, like the soil we walk on. It is always there. It doesn't depend on anything. It is independent. Whereas the y-axis is like a building that goes on top of the ground. It is dependent on the ground. If there was an earthquake and the ground shook, then that building would fall down because it's dependent on the ground being there. So this is our y and our x. The y-axis is like a building. It depends on the ground being solid. So it is dependent, depends, and our x-axis is always there. It is independent. It doesn't depend on anything. It is always there. So that's how you figure out the independent and the dependent variables. Independent is x-axis, dependent is y-axis.